Diamonds are some of the most fascinating materials on Earth. Formed under crushing pressure deep below the surface, carried upward by violent volcanic events, and then transformed by human engineering into perfectly sparkling gems that can last forever. What ends up on a ring or inside a luxury display case begins as carbon atoms locked in the mantle for billions of years, then passes through mining, heavy crushing, advanced sorting, precision cutting, and microscopic polishing before it ever reflects a single beam of light. Diamonds may be famous for beauty, but their journey is one of geology, industrial machinery, and extreme craftsmanship. And today on the How Factory, we're going deep into the world of diamonds to see exactly how diamonds are made. From deep earth to perfectly cut gems. The story begins far below our feet, around 140 to 200 kilometers underground in Earth's mantle. Down there, pressure is so intense that carbon atoms can be forced into an ultra-tight crystal lattice, forming diamond, the hardest natural material known. This is not a quick process. Many diamonds are believed to be over 1 billion years old. They formed long before humans existed, locked in ancient rock, invisible and unreachable for most of Earth's history. What brings them to the surface is one of the most powerful natural forces on the planet: deep volcanic eruptions. Diamonds reach the surface through rare magma channels called kimberlite or lamproite pipes. These eruptions blast material from deep in the mantle upwards so quickly that diamonds survive without turning back into graphite. Over time, erosion breaks down these volcanic pipes, scattering diamonds into riverbeds and coastal deposits. That's why diamonds are mined in two main ways: primary mining from kimberlite pipes, and secondary mining from alluvial deposits where diamonds have been naturally transported. Modern diamond mining begins with geological exploration. Companies use airborne magnetic surveys, drilling, and rock sampling to locate kimberlite deposits. Because diamonds are rare, mines must process enormous volumes of rock to recover small amounts of gemstones. Once a deposit is confirmed, mining operations begin. In open-pit diamond mining, massive excavators and haul trucks remove layers of earth to access kimberlite ore. The pits can become gigantic, resembling inverted mountains. If deposits extend deeper, mining shifts underground, with tunnels and shafts following the ore body into the earth. In alluvial mining, operations extract gravel and sand from rivers or ancient seabeds, using dredges and screening systems to recover diamond-bearing material. Once ore reaches the processing plant, the real industrial work begins. The ore is dumped into crushers that break huge rocks into smaller pieces. This crushing must be controlled carefully. Diamonds are extremely hard, but they can still crack or shatter if hit the wrong way. After initial crushing, ore passes through grinding mills and sizing screens, reducing it to manageable particle sizes while minimizing diamond damage. After crushing, the material enters washing and separation stages. Diamond processing relies heavily on density because diamonds are heavier than most surrounding minerals. In dense media separation systems, ore is mixed with a slurry of finely ground material that creates a liquid of controlled density. Lighter waste floats while heavy material sinks. This concentrates the diamond-bearing fraction, drastically reducing volume. Next comes one of the most advanced parts of modern mining: sensor-based sorting. Concentrated material passes under X-ray fluorescent scanners. Diamonds glow under X-rays in a way many other minerals do not, allowing machines to identify them in milliseconds. When a diamond is detected, air jets blast it into a separate recovery bin. Optical cameras and laser systems may also be used to detect unusual stones and remove waste. Recovered diamonds at this stage are still rough stones, covered in natural surfaces and often embedded with imperfections. They are cleaned, logged, and sent to sorting facilities where gemologists and technicians categorize them by size, clarity, shape, and color. Rough diamonds vary enormously. Some are clear and gem quality. Others are industrial grade, used for cutting tools, drill bits, and abrasives. Only a portion becomes jewelry. For gem-quality diamonds, the next phase is planning, where technology meets artistry. Before cutting begins, the rough diamond is scanned using 3D imaging systems. These scans reveal internal inclusions and fractures. Cutting planners use software to map the optimal cuts that maximize value. This is one of the most important decisions in diamond manufacturing. A single rough stone can produce different outcomes depending on how it's cut. One large diamond or several smaller ones. The planner chooses a strategy that balances size, clarity, and sparkle. Once the plan is set, the diamond enters the cutting stage. Traditionally, diamonds were cleaved, split along natural crystal planes, but modern cutting uses precision sawing and laser technology. Some stones are cut using diamond-coated saw blades, while others are sliced using lasers for maximum control. The goal is to shape the rough stone into a manageable form called a preform, which resembles the final gem but without precise facets. After sawing, the diamond is shaped through bruting, the process of forming the girdle, the outer edge of the stone. Bruting is often done by spinning two diamonds against each other, grinding them into round shapes. Today, automated bruting machines control speed and pressure with incredible precision, ensuring symmetry. Now comes faceting, where the diamond's final brilliance is created. Faceting involves cutting flat surfaces at exact angles so light enters the stone, reflects internally, and returns through the top as sparkle. Diamonds are mounted into holders and pressed against spinning polishing wheels coated with diamond powder. Because only diamond can cut diamond effectively, the process uses diamond abrasives. Each facet must be cut to precise angles measured in fractions of a degree. The modern round brilliant cut, the most popular style, includes 57 or 58 facets depending on the design. Each facet influences how light behaves inside the stone. If angles are wrong, light leaks out and the diamond appears dull. If symmetry is off, sparkle becomes uneven. That's why diamond cutting combines machines and human skill. Even with automation, master cutters rely on experience to guide decisions. Polishing is the final refinement. Polishing smooths each facet until it becomes mirror-like. This is what creates sharp reflections and high brilliance. Polishing takes time because removing too much material can ruin symmetry. Diamonds are checked constantly under microscopes to ensure perfect finish. Once cut and polished, diamonds move to grading. Independent gem laboratories evaluate diamonds based on the famous 4 C's: carat weight, cut quality, color, and clarity. Cut quality is often the most important for sparkle, because even a high-carat diamond can look lifeless if cut poorly. Color grades measure how colorless the diamond is, while clarity grades measure internal inclusions and surface blemishes. These grades determine the diamond's market value. After grading, diamonds are cleaned ultrasonically to remove polishing residues, then inspected again under controlled lighting. They may be laser inscribed with certification numbers for authentication. Finally, the diamonds are packaged for jewelers and manufacturers. From here, diamonds enter jewelry production. Jewelers design rings, necklaces, and earrings, setting diamonds into metal mounts made from gold, platinum, or other alloys. Setting is another precision craft. Prongs must hold the stone securely without blocking light, and the setting must protect the diamond while showcasing its sparkle. Behind the beauty, diamonds also have major industrial roles. Industrial diamonds and synthetic diamonds are used in cutting tools, precision grinding, drilling, and electronics. But natural gem diamonds remain unique for their rarity and geological history. Each one is a piece of Earth's deep interior, brought to the surface by ancient forces. What makes the diamond journey so remarkable is its timescale. Nature takes billions of years to form a rough diamond, yet humans can transform it into a perfectly cut gem in weeks, using crushing plants the size of factories and polishing systems accurate to microscopic levels. It is geology turned into luxury through engineering. From deep mantle pressure and volcanic eruption, to mining pits and crushing plants, from X-ray sorting and scanning, to laser cutting and ultra-precise faceting, the process behind a diamond is one of the most dramatic transformations in the natural and manufactured world. And that is exactly how diamonds are formed, mined, separated, cut, polished, graded, and turned into perfect gems, transforming deep earth carbon into sparkling stones prized across the world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the materials, machines, and industries behind the world's most iconic products.